Let's just do a couple of examples of ellipses. Now, this one has given me the vertices of the ellipse. And as we talked in class the other day when we were going ellipses, we had two sets of vertices. We had the majors and the minors. Typically, we only talk about the majors. So when you see, tell me what your vertices are, and it only gives you an option of putting down one answer, that's typically talking about the majors. We do have majors and minors. So let's go ahead and put our majors and minors on here, and then we'll check out which one is which. My vertices are at negative and positive 4, 0, and 0, positive, and negative 16. So in my grid, let's make each one of my grid marks worth 2. So this is negative 2, this is negative 4. So this is negative 4, 0. And then 2 and 4, so this is 4, 0. I'm going to do the same thing with my 0 and negative 16. So 2, 4, 6, 8, 10, 12, 14, 16. 0, negative 16. And 16. So 1, 2, 4, 6, 8, 10, 12, and 16. So this is 0, 16. Now, I know which one is the larger one by looking at my graph, if I didn't know by looking at my ordered pairs. Because my larger numbers are the 16, that means A has to equal 16. That also means because my larger numbers are running on my x or my y-axis, that means my A value must be under the y part. And my vertices are positive and negative 4, 0, 0, positive, and negative 16. Because they are symmetric with the origin, that means I'm on the origin. And so my equation is y squared over b squared plus x squared over b squared plus y squared over a squared is equal to 1. My a value is the distance from the origin to the major vertice, and my b value is the distance from the origin to my minor, so that b is going to be equal to 4. So filling out the equation over here, I have x squared over 4 squared plus y squared over 16 squared is equal to 1. And that's the equation of that particular ellipse. Now, let's see if I can draw this ellipse with the help of my drawing tool. Hopefully it'll recognize this as an ellipse. Nope, it did not. Okay, let's try this again. My drawings are so beautiful. Let's see if it'll match this ellipse. Maybe if I try to draw it just a little bit better as an ellipse. There we go. There's my ellipse. Obviously not hitting all the points that it should have, but at least it recognizes that an ellipse, and that's what the graph should look like, give or take. So on this example down here, they're asking me to find the equation of the ellipse that has been translated so its center is at the origin. So this is my equation. My equation is x minus 7 over 6 squared plus y plus 7 over 3, the quantity squared is equal to 1. This is what the graph looks like for that. Is my center is at 7, negative 7, and my distance from from my center to my major vertex is 6, and then my distance from the center to my minor vertex is 3. If we want to translate this, pick this up and set it so it is at the origin, we want the center to be here. But what we also want is to save that 6 distance and that 3 distance. So I still need to go from the center to my major to be 6. So right there and right there is where my major vertices must be. They must be still to maintain that shape. All we're doing is moving it to the origin. It must be at 6, 0, and it must be at negative 6, 0. I also have to maintain the distance from the center to my minors to still be 3. So I'm going to go from the center down 3. So my minor is at 0, comma, negative 3. I must go up 3 from the center, so that must be 0, comma, positive 3. So my ellipse, let's see if I can draw the ellipse a little bit better, is going to go through those points. See if this is going to say, I know that looks like an ellipse. It did. Still doesn't quite match it right, but there's my ellipse. Now, if I have maintained that same a value and that same b value, then the equation of my ellipse that's been translated back to the origin should be x squared over my distance from the center to my minor, which is 6 squared, plus y squared, and then that distance must still be maintained, so it must be 3 squared is equal to 1. So my equation is x squared over 36 plus y squared over 9 has to equal 1. And that is the equation of my ellipse that has been translated back to the origin.